Hello, in this video, we're going to discuss how many solutions does this equation has for different values of a. So the equation is ln absolute x over x is equal to ln absolute a over a. So x is the unknown and a is a constant. So since here is a absolute value sign and absolute value sign here, so we're going to discuss positive x, negative x, positive a, negative a. So this is going to be crazy, but we're going to figure it out in this video. So to answer a question, we set a function fx is equal to ln absolute x over x. So since here is a absolute value sign and we have two cases, when x is negative, it is equal to ln negative x over x. When x is positive, it is equal to ln x over x. So as we normally did, we differentiate fx to get the derivative of fx. So fx prime is equal to, so obviously there are two cases. When x is negative, it is equal to 1 minus ln negative x over x squared. When x is positive, it is equal to 1 minus ln x over x squared. So we let fx prime is equal to 0. So when this is equal to 0, and we got x is equal to positive and negative e, so this is equal to 0, the answer is x is equal to negative e, and this is equal to 0, and we get x is equal to e. So with this cutoff values, we were able to discuss how fx change with x. So when x is less than negative e, x is less than negative e, so x is negative, and we're going to say this function, the fx prime, and this is going to be negative, so fx prime is going to be negative, and fx decrease in this range. When x is equal to negative e, fx prime is equal to 0, and fx is equal to negative ln e over e. When x is greater than negative e and is less than 0, so it's still negative, and let's look at this equation here. So this is going to be positive, so fx prime is going to be positive, and fx increase in this range. When x greater than 0 and is less than e, so this time x is positive, and we look at this expression. So this is going to be positive. So fx prime is positive and fx increase in this range. When x is equal to e, fx prime is equal to 0, and fx is equal to ln e over e. When x is greater than e, so it's positive, and we look at this. So this is going to be negative. Fx prime is negative, and fx decrease in this range. So with these discussions, we got an general idea of what the graph of fx looks like. So here I just directly bring up the graph of fx. So it's something like this. Here in this range, decrease, and here when x is equal to negative e, here is a local minimum, and then increase in this range. Again, on the positive side, and increase in this range, and here is a local maximum when x is equal to e, and then decrease in this range. So since we're going to determine how many solutions of the original equation, so what we need to know is the intersections between the graph of fx and the level of ln absolute a over a. So we have to evaluate the upper limit of the function, the two upper limits, and the two lower limits, and the local minimum, local maximum. So we need to evaluate these levels and to say if there is intersections with the level of ln absolute a over a. So what we already have is the local minimum. That is when x is equal to negative e and y is equal to negative ln e over e. And the local maximum is as x is equal to e and y is equal to ln e over e. So what we need to evaluate is the two upper limit and the two lower limit. So here on the left side, and there is when x, here is when x is approaching negative infinity. So this is one upper limit, and here is the other upper limit when x is approaching 0 from the negative side, and this is the lower limit when x is approaching 0 from the positive side, and here is another lower limit when x is approaching positive infinity. So let's calculate the first limit when x is approaching negative infinity. So fx is negative. It is equal to ln negative x over x. So when x is approaching negative infinity, ln negative x is going to be positive infinity, and x is negative infinity. So the numerator is positive infinity, and the denominator is negative infinity. So this is going to be infinity over infinity. So we can use the L'Hospital's rule that the limit if a ratio and it is equal to the limit of the ratio of the derivatives of the numerator and the denominator. So L'Hospital's rule. So let's look at the ratio of the derivatives of the two functions as on the denominator and the numerator. So this is going to be, so the derivative of the numerator is 1 over x and the derivative of the denominator is 1. So this is equal to 1 over x over 1 when x is approaching negative infinity. So this is going to be 0. So now we got the upper limit on this side, that is 0 right here, and then we calculate this one when x is approaching 0 from the negative side. So x is negative and fx is equal to ln negative x over x. So this, when x is approaching 0 from the negative side, this is going to be negative infinity, and this is 0 from the negative side. So this is going to be positive infinity. So now we got the other upper limit is 0. So from the negative side, and it's going to be positive infinity. And then we look at this one, and when x is approaching 0 from the positive side, and fx is equal to ln x over x, then x is approaching 0 from the positive side. This is going to be negative infinity, and this is going to be positive. This is going to be 0. So this is equal to negative infinity. So this side, this is 0 and negative infinity. So when x is approaching positive 0, and the limit of fx is negative infinity. So let's calculate this one. So here again, x is positive and fx is equal to ln x over x. So when x is approaching positive infinity, ln x is going to be positive infinity, and x is positive infinity. So here again, infinity over infinity. So we're going to use the L'Hospital's rule, and this limit is equal to the limit of the derivatives of the numerator and the denominator. So let's calculate the derivatives of the numerator and denominator. So here, again, the derivatives of ln x is 1 over x, and the derivative of x is 1. So here it's equal to 1 over x over 1, and when x is approaching positive infinity, this is going to be 0. So now we get the other lower limit when x is approaching positive infinity and the limit is 0. So with this two upper limit and the lower limit and the local minimum, local maximum, we will be able to discuss. So we have this 6 points. With this, we will be able to discuss the number of intersections or number of solutions of fx with the level of ln absolute x over absolute a over a. So when ln absolute a over a is less than negative ln e over e, so it's less, so it's in this area, so there will be one intersection in this area with the function of ln absolute x over x. So there will be one intersection and one solution. So when ln absolute a over a is equal to negative ln e over e, so this straight line, so there will be two intersections. You see here, one is here and the other is here. So there will be two intersections and two solutions. When ln absolute a over a is greater than negative ln e over e and this is smaller than 0, so it's in this area, so there will be three intersections. One is this side, the other is this side, and the third one is positive side. So 2 negative 1 and 1 positive 1. So there will be 3 intersections and 3 solutions. So when ln absolute a over a is equal to 0, so this is going to be this straight line equal to 0, and there are 2 intersections right here, 2 intersections. One is positive, one is negative. So there will be 2 solutions, 2 intersections and 2 solutions. When ln absolute a over a is greater than 0 and less than ln e over e, so it's in this area. So you will say there will be 3 intersections. So one is on the negative side and the 2 will be on the positive side. So 3 intersections and 3 solutions. So when ln absolute a over a is equal to ln e over e, so this straight line is equal to this level is ln e over e. So there will be 2 intersections. So one is negative right here, and the other is positive, is at x is equal to e. So there will be 2 intersections and 2 solutions. And when ln absolute a over a is greater than ln e over e, so it's greater than this. So it's in this area. It's greater than this level. So there will be 1 intersection on the left side, on the negative side, in this area. So there will be 1 solution. So with this, we discussed the range of ln absolute a over a and the corresponding number of solutions. So the target is the range of a, the value a, different values of a, and the corresponding number of solutions. So remember, ln absolute a over a, so obviously there are also 2 cases. When a is negative, it is equal to ln negative a over a. When a is positive, it is equal to ln a over a. So to discuss the range of a and the corresponding number of solutions, so we have to look at the cutoff values. So, and to solve these 4 equations. So when a is positive or is negative, and to solve this equation, when a is positive and solve this equation at the same level, negative lnE over e, negative lnE over e, these two equations correspond to this equation with a absolute value sign here. So, and these two equations correspond to this equation with a absolute value sign. So obviously, at this level, negative lnE over e, when a is negative, there will be only one intersection when a is negative. So that is a is equal to negative e. And with this level, lnE over e, when a is positive, so there will be only one intersection on the positive side. So that is a is equal to e. So let's look at these two straight lines. So there are two intersections. So where no one intersection is at x is equal to negative e or x is equal to e. So what we need to solve or find the value is this intersection and this intersection and the corresponding value of e. So we are going to solve these two equations. So the two equations are right here. So we'll start from the left side. And this equation can goes to, so here 1 over a can be a to the power of negative 1, and we put a negative sign in the brackets, and outside the bracket this will not change things. So this is 1 over a, and we keep ln negative a, and it is equal to, so this is equal to 1 over e. So with this, negative a is equal to e to the power of ln negative a. So we replace negative a with e to the power of ln negative a. So here we replace this negative a with e to the power of ln negative a, and we get this equation. Then negative 1 can be moved from here to here. So we moved negative 1 from the power to times the ln negative a. So we have this equation. So here is a negative sign, and we keep this part, and we get this equation. So you see this equation is something times e to the power of something is equal to 1 over e. So we can use number w function to get the value of a here. So something times e to the power of something is equal to 1 over e. So number w function. So I'm not going into details about this function, but you can simply take it as the inverse function of x times e to the power of x. So it can be described as x is equal to w is number w function of x times e to the power of x. So here x is equal to this part, negative ln negative a. So negative ln negative a, so this is x right here, is equal to number w function of 1 over e. Number w function of something times e to the power of something, that is 1 over e. So we just directly bring up a number w function calculator right here. So since 1 over e is equal to this value, so we just put this value into the arguments into this box, and x is equal to this value, and we can click compute, and we get the value of the number w function of this. So this is equal to right here, the number right here. Then a is equal to negative e to the power of this value, and it is equal to negative 0.757. So we got the solution of this equation. We got the solution of this equation when a is negative. analogously, for this equation, we use the same strategy, same approach, and we can get A is equal to 0.757. So this is the solution of this equation when A is positive. With this, we know that this equation has solution of A is equal to negative E when A is negative. This equation has solution of negative 0.757 when A is negative. This equation has solution 0.757 when A is positive. And this equation has solution A is equal to E when A is positive. Also, there is one more cutoff value is ln absolute A over A is equal to 0. So A is going to be positive and negative 1. So this is the solution of this equation. So with these cutoff values, we will be able to discuss the range of A and the corresponding number of solutions. So in this case, one solution, that's it in this area. So A is only in the positive range, that is 0 from this value right here, 0.757. So for two solutions, ln absolute A over A is equal to negative ln E over E. So two solutions. So for two solutions, so it is equal to negative ln E over E. So it's in this straight line. So we'll say there are two intersections. That is A is equal to negative E or 0.757. So right here, the corresponding A value of this intersection. So the intersection here and the corresponding A value is 0.757. And when ln absolute A over A is in this area, it's greater than negative ln E over E and is less than 0. So it in this area there are three solutions, and the corresponding range of A, we say from negative infinity to this value is negative E, and then negative E to its value is negative 1. So this is negative infinity to negative E, and from negative E to negative 1. So this is on the negative side. And on the positive side, let's say here is 0.757 to 1. So this is the range of A and has three solutions. Then when ln absolute A over A is equal to 0, so it's this straight line, there are two solutions and the corresponding A value is positive and negative 1. So this is simple. And when ln A over A is in this range, it's greater than 0 and less than ln E over E is in this area, there are also three solutions. And on the negative side, that is from negative 1 to negative 0.757. So this is the negative side. And the positive side is from here is 1 to E. Here is 1 to E and E to the positive infinity. So these two range. So when A is in this range, there are three solutions. When ln absolute A over A is equal to ln E over E, so this straight line, there are two solutions. And there are two values of A. So one is here is negative 0.757, and the other is positive is E. So negative 0.757 and positive 1 is E. Then when ln absolute A over A is greater than ln E over E. So there's one solution when A is negative. When A is negative, so in this range is negative 0.757 to 0. So now we discussed the range of A and the corresponding number of solutions, and we are close to the final answer. So we are close to the final answer, and we can make conclusions. When A is so in this range and this range, so from 0 to 0.757, and from negative 0.757 to 0, the original equation has one solution. So when A is equal to positive negative 0.757, positive negative 1, positive negative E, so this straight line, there are two intersections and two solutions. So when A on left side is from negative infinity, so right here negative infinity to E, and from negative E to negative 1, and from negative 1 to negative 0.757, and so it's in this area. And on the right side, from 0.757 to 1 to E, and 1 and E to positive infinity. So in this range, there are 3 intersections and 3 solutions. So this will bring up the end of this video. Thanks for watching. I would appreciate if you subscribe to this channel for more videos. I will see you in the next video. Thanks. Bye.